Okay, pre-cal, we are in Unit 7, Topic 3, and we are going to conclude Topic 3 with these two examples. So, of course, I've got my unit circle here for convenience, and number 10 tells me that I have cosine squared x equals 3 sine squared x for 0 degrees to 360. So this is a restriction. This means that no matter how many values occur on the unit circle, I just care about them once. I don't have to add anything to my solutions for rotation. So the only problem with this is that we are not all using cosine and sine. It's kind of like having an equation with two variables in it. But lucky for us, we have our identities that we know about, so we can manipulate this and change either sine squared x to 1 minus cosine squared x, or I can change cosine squared x to 1 minus sine squared x. It really doesn't matter to me which one you use, but if you will recall from our identities page, I can use either one of these. Okay, so it doesn't matter to me which one you use. I'm just going to change everything to cosine squared theta. So cosine squared x equals 3 times, I'm just going to replace this sine squared x with 1 minus cosine squared x, just like that. And then what I'm going to do is do a little bit of, algebraic manipulation here. I'm going to distribute this 3. Okay, notice that I've got negative 3 cosine squared x. So I'm going to add these to both sides. So that ends up giving me 4 cosine squared x equals 3. And then I'm going to divide both sides by 4. And then I'm going to take the square root. Remember, plus or minus the square root. So I end up with cosine x equaling the square root, plus or minus the square root of 3 over 2. And this does occur on the unit circle, so that makes me happy. So cosine positive radical 3 over 2 right here and right here. Negative radical 3 over 2 right here and right here. So it occurs 4 times on the unit circle. I do not have to add anything to my solutions because I'm restricted to only once around the circle. So x is going to be, and it's also going to be in degrees. Notice your restrictions are in degrees. That's how you can tell that. So this is occurring at 30 degrees, 150 degrees, 210 degrees, and 330 degrees. Beautiful. Okay, let's look at number 11. Let me erase my unit circle here. Okay, so I've got 2 tangent x minus radical 3 equals tangent x. Remember, I have to get all of my tangents on one side, so I am going to do a little switcheroony here. I'm going to add radical 3 to both sides first. And then I'm going to subtract tangent x. So I end up with 1 tangent x equals positive radical 3. Easy peasy. All right, so where does tangent have radical 3 as its solution on the unit circle? Well, remember, tangent is sine divided by cosine. So I am going to get radical 3 everywhere I divide radical 3 over 2 by 1/2. So that is going to be, I'm sorry, I said that incorrectly, I think. Okay, let me think about this. I don't know what I'm thinking. So tangent x is your sine over your cosine. So this value is going to occur here. Sorry about that. Radical 3 over 2 divided by 1/2. Remember, radical 3 over 2 times 2 over 1. Okay, so that is going to occur right here. And notice there are no restrictions, so I have to account for all rotations along the circle. So X is going to be equal to 60 degrees. We're not told it's degrees in the problem, but earlier in the last video at the very top, see, it's in degrees. Okay, man, I'm kind of losing it on this problem. I don't know what's wrong with me, kids. I'm so sorry. Okay, so plus, and remember it's going to occur right here as well. Okay, so that is going to be plus 180. You don't also have to write the 240 plus 180 degrees in, but you can if you want to. You just really have to use it once though, because every rotation it's going to hit that value again and hit it there and there and there. See what I'm saying? Okay, I know that's hard to understand, but that's why we do that. Okay?